So write down the next heading. This is a very, very, very important one. That is projection of uniform circular motion on simple harmonic motion. Right? So what is a uniform circular motion? Is it periodic or oscillatory or both? When a particle is moving in a uniform circular motion, is it, I'll give you options. You think and tell me. Is it only periodic? Is it only oscillatory? Two options. Is it only periodic or only oscillatory?
Periodic, sir.
It is only periodic motion. It is not oscillatory because it is not revolving about a mean position. Rather, it is moving in a fixed path. I hope you understood the difference between periodic and oscillatory. For oscillatory motion, for you to call any motion to be oscillatory, you need a fixed point. What is the name of that fixed point called as?
Mean position, sir.
You need a mean position. Without a mean position, you cannot call anything as a oscillatory motion. So here, one important conclusion that we can draw is, I'll give you a statement. You guys think and tell me again. Can I say every periodic motion is oscillatory? Is my statement true or wrong? False. Every periodic motion is oscillatory.
No, sir.
No. But the vice versa, that is, every oscillatory motion is periodic.
Yes, sir.
Yes, it is. Right, because every oscillatory motion has an important parameter associated with it. What is it called as? It's called as time period. Okay, and it also has the mean position concept. Are you able to understand? So now what we are going to see is projection of uniform circular motion on simple harmonic motion. So I'm going to show you a video. See, observe, okay? I'll be narrating it. You will not be able to hear anything, but concentrate. So there is a purple color ball that you're able to see. Now tell me how it is actually moving.
A very interesting point about a simple motion.
It's a to and fro motion about some fixed point. Let's say the length of the line is L, the mean position will be at L by 2. It is oscillating about that position. So can I call this as a vibratory motion? Right. As of now, I'm not calling anything as simple harmonic. Can I call this as a vibratory motion?
Yes, sir.
Right. Now see what is going to happen.
Motion is that it can be considered as a projection of a uniform circular motion.
So was the particle actually moving in a straight line path?
Sir.
Did you understand? Was the particle actually moving in a straight line path? Observe it again, okay? Be careful. So here when you see,
about a simple
you're able to see, when you're looking at it, you're able to see that the particle is in straight line
as a
motion.
projection.
But actually, where is it rotating?
Of a uniform circular motion.
It is actually in what kind of motion?
A uniform circular
motion.
It is actually a uniform circular motion, but when you see from the side, okay, that is, when you have a circle like this, when you see from this side, no, what will you be able to see? You'll only be able to see this curvature, no, this curvature like a straight line. Are you able to see me? So listen, I have the state. The particle is revolving like this. Okay, the particle is actually revolving like this. But whereas when I see from this side, what am I able to see? Am I able to see the other side? You're able to understand. The particle is actually revolving like this. Now, I will take my hand and show it in this way. How are you able to see my hand? It will appear, see, actually this is fat. Okay, if it is thin enough, you can observe that the hand is actually moving like this. That's what you saw in the video. Are you guys able to visualize what I'm trying to say?
Yes, sir.
That's what is called as projection. Okay, projection is actually viewing from different angle. So it is circle is 2 dimension, but when you see from the side of the circle, it is appearing like 1 dimension. Correct? Huh? So now see what exactly is going to happen.
When viewed sideways.
Now see.
is a simple harmonic motion. We can also consider a simple harmonic motion.
Okay, suppose
shadow
when the ball is
of a
revolving, I keep a ball in the side and I try to capture the motion of the ball alone. If I try to capture the shadow of the ball alone, then how is it going to appear? Look at the ball, look at the shadow on the right.
Circular motion.
So the ball is actually revolving in circular path, but how is the shadow moving?
Up and down, sir.
It is moving up and down. So this is what is meant by
Let us say
projection of a
that the
uniform
angular
circular
speed of a
motion
particle
as a simple harmonic
moving
motion.
along a circular path of radius
Are you able
L
to visualize this point?
is equal to omega. If the particle starts from this position, then after time t,
Yes.
its angular displacement.
So now I can show you things better. Suppose the particle is revolving in a circular path. This is the wall. Okay. And let's say there is a red color ball which has started from here. Okay. Now, where will the shadow of this ball be? It will exactly be somewhere over here. Correct? Let's say the particle is revolving in anti-clockwise direction with an angular velocity omega. If the particle is stopping here from P, let's say it is stopping at P dash, then it would have swept an angle theta at the center. Correct? So it would have swept an angle theta at the center. Now, where will the position of P dash get captured on the wall? If I just drop a perpendicular from here to here, then the particle will be somewhere over here. So this is the projection of P on the wall. This is the projection of P dash on the wall. Is it clear till this point? Right. Similarly, had the particle been here, this is P double dash. Right. So with respect to the center to this height, what is this distance called as? It is the radius. Right. In terms of circle, the distance between O and P dash can be called as the radius. Correct? Similarly, in terms of simple harmonic, in terms of oscillatory motion, what can I call this distance OPP dash as? So after P double dash, it will come somewhere over here, P triple dash. Right. Again, there will be another point here where it will appear like this. Correct? Let me call it as P triple dash, something like this. Then this distances are, then how much is this distance in terms of an oscillatory motion? I've given the hint.
Amplitude, sir.
Yes. Is it not the amplitude? Because the particle cannot go beyond the circle. No, it cannot come out. So the extreme points of the circle in the vertical, that is the extreme ends of the diameter, is going to define the amplitude of whom? Amplitude of the projected simple harmonic motion. Is that clear? So the radius of the circle is equal to the amplitude of the simple harmonic motion when you're treating that circle as the projection on the wall. Does it make sense, guys? So if I erase all these points, okay, my interest of study is, if I consider the circle to have a radius of A, where A defines the amplitude of the simple harmonic motion. Okay, so I hope now you understood why the radius is equal to A. So let's say the particle started at point P at t is equal to 0 and it is at P dash at some time t. Correct? Now I'm interested to find the coordinates of this point at time t. So if I take this distance as x and this distance as y, then what can I say that y divided by a is equal to? If I take the right angle triangle, what is y divided by a?
Sin x.
That is not sin x, sin theta. Correct? Let this be equation number 1. We know that theta is equal to omega naught into t plus half into alpha t square. I've told you in the rotational motion also. So this equation is applicable for circular motion also as well. So theta will be equal to, in the place of omega naught, I will write it as omega into t plus, when the object is in uniform circular motion, alpha will be 0. So theta can be replaced with omega t. Let this be equation number 2. If I take and substitute it here, then y will be equal to what? A times sine theta, which is nothing but a times sine of omega t. So y is equal to a sine omega t is the displacement equation of the particle in SHM, because this distance y is same as the distance OP dash. Is this clear?
Yes, sir.
Please make a note of this. So y is equal to a sine omega t, or x is equal to a cos omega t. A cos omega t also you will get by using x by a is equal to cos theta.
So, sir, here A is the radius, sir.
A is the amplitude. Forget about radius now, because we try to extract everything from the circular motion. Here, A is the amplitude of whom? Amplitude of SHM, which is also equal to radius of circular motion. Got it?
Okay, sir, understood.
Okay. Now
I
listen.
actually have one more doubt.
Tell me.
Here we considered even y as an amplitude, right, sir? It's the maximum
Why is
distance.
not amplitude? Why is the instantaneous displacement? Why is dependent on time? Right?
Okay, sir, understood.
Yeah. Okay. So y represents the displacement of the particle in vertical direction. X represents the displacement of particle in horizontal direction. See, this equation will also be taught in your school, but I'll give a clarity about this in the next class. As of now, don't worry about X. Concentrate only on Y. Okay. So displacement of a particle is y is equal to a sine omega t. If I do dy by dt, what am I going to get? A into d by dt of sine omega t. Okay. So by now, you people know what is chain rule, right? So A into, what is the derivative of sine omega t? What is the derivative of sine? It is cos, right? Cos of what? Cos of the same angle into d by dt of, you need to differentiate the angle inside, that is omega t, right? So A cos omega t into d by dt of omega t, that will be A omega into cos omega t. So, but what is dy by dt according to physics? What is the rate of change of displacement?
Velocity.
Velocity. So this is the velocity of the particle, which is given by A omega into cos omega t. So this is 1, this is 2. Okay, I'll finish the next step also. Derivative of velocity, Vp means velocity of particle. Okay, or I will write only V. dV by dt is what? A omega into d by dt of cos omega t. Now you guys tell me how to apply chain rule. That is A omega into derivative of cos is minus sine omega t into what should I do to omega t? D by dt of omega t. Correct? So A omega into minus sine omega t into d by dt of omega t is how much? A omega into minus sine omega t into derivative of omega t is omega. So multiply both minus A omega square sine omega t. But what is A sine omega t, guys?
Why?
So, yes. So can I write this as minus omega square into A sine omega t, which is nothing but minus omega square y. And what is dv by dt? It is acceleration. So A is equal to minus omega square y. How does it look like? Is this not the mathematical equation for SHM? Guys, are you able to understand?
Yes, sir.
So mathematics is also supporting it. So A is equal to minus omega square y represents the equation of particle in SHM. And as I mentioned, this is a very, very, very important relation.
Yes, the equation for acceleration and simple harmonic motion.
Yes, it is the equation of acceleration of particle in SHM. So going forward, there will be questions like this. You need to find the time period of some particle. So during that time, we will be using this equation only to prove that the particle is in SHM. So have this in your mind. Okay. So I've taught the basics. So make a note of this. Next class, I will show you why this x is equal to a cos omega t has actually come. That is what is meant by this horizontal.